Right, in this section on strings, we'll look at string variables, which will really just be character arrays. Right, so we looked at string literals in the previous section, but we'll now, like I said, we'll take a look at them as character arrays. And we already know how to create arrays of other data types, right? Ints, doubles, floats, things like those types. So we'll take a look at a string is simply a one-dimensional character array, right? We're going to declare its length like any other array. We always need to leave room for the null terminator. We saw that when we were working with string literals that it was saving this \0, which is called this null terminator for strings, at the end of the string. Right? So whenever you declare the size of the array, you want to remember to leave room for the null terminator. So if you need to create an array that has room for 80 characters, you'd want to say length plus 1. Now, if your 80 included the null terminator, you could just say length. So it all depends on your application, right? So if you want to make sure that you have room for at least 80 characters here, that's why we're saying length plus 1. Now, the length of the string doesn't have to use all 80 characters, right? If we create an array that's 80 long, but we only store 5 characters in there, we use that null terminator to then say where the end of that string is. So our string length depends on the position of the null terminator, right? And we can initialize string variables the same way we use the initializer list for arrays, very similarly. So we can initialize them when we declare them. So in this example here, name is an array that is 8 characters long, right? Its data type is char. But notice then, instead of the initializer list that we had with the curly braces for other data types, here we simply have the character string inside double quotes. Right. What it does then is this: we create an array that has 8 elements, so it has room to store 8 elements. But notice then that this string here, S-A-R-A-H, Sarah, only has 5. So the first character, the capital S, gets stored at index 0. The next one at index 1, 2, 3, 4. So there's our 5 positions. What it does then is it null terminate. It places the null terminator here at position index 5, and it just goes ahead and places the null terminator in the rest of the string. Because we've seen before with arrays with initializer lists, it initializes anything else we don't to 0, and basically this is very similar to a 0, that null terminator, right? And then if the array is too long, there won't be any null terminator. So if we had more characters here than what we declared in the array, it would fill up all of these spaces and not leave any room for the null terminator. Of course, that's not something we desire to do. So we always want to make sure this is long enough to hold our information or to store that information. We've seen before with string literals that a common error is to declare a pointer. In this case, notice that P is a pointer to a char data type. And if you were to say something like P at index 0, if you wanted to store the character A in there, you can't do that simply because P is not pointing to any area of memory where it can store it. Remember, P needs to point to some sort of area of memory where it can store the information. So that would be incorrect. There's no memory allocated. But in this case, let's take a look here. We're creating an array of 10 chars. Say ARR is the name of that array. There's 10. And then star P says that P is a pointer to a char data type. We can then make P point to A simply by assigning the name ARR, because remember the name of an array is a pointer to the start of that array, to P. P will now point at this array ARR. And now you can say P at index 0, you can write information to that location, simply because now P points to some allocated memory space. Remember then with pointers, right, before you can start using any array notation or indirection operations with them, they have to be pointing to some sort of memory space. We can read strings with Scanf, right? And we use the %s conversion specifier to do that. We saw that example before with string literals in the previous video. Here we've got our array, then ARR has 10. I've initialized it then with this initializer list, so it has ABC stored followed by the null terminator. Now here's then another character array named line that's 80 characters long. Right. So in this case, if I wanted to print out what was in ARR, I use %s, give it the name ARR. It will print then ABC. It won't print those null terminators. That null terminating character says we don't print that. So it'll print A, B, and C. It'll print everything in this array until it finds a null terminator. Here, we're using then scanf to read some information and store it in the array named line. And we use %s to do that. Right? And as we saw in the previous example, we don't want to enter anything that's more than 8 characters long or we'll overwrite the memory. So we could put something in the width specifier if we wanted to limit the amount of information we read. And notice then this says no ampersand. So the ampersand is the address operators needed Y. Remember, the name of an array is an area of memory. So this is already, the name of the array is already saying basically the same thing as the address of that. So you can use this without the address operator. Right? And we want to talk about how scanf reads things in. We noticed then with integers, doubles, things like that, the pattern matching for those numbers were to skip over any leading white space. And it does the same thing for strings. So it will skip over when reading in a string any leading white space. Remind you that white space are blank spaces, tabs, new line characters. It's going to read characters until it encounters white space. So it's going to keep reading one character after another until it encounters some sort of white space. It'll read that in, and then it will automatically store a null terminator at that string's end for you. All right, sorry, I went up instead of down. All right, so let's take a look at example 05. And we're going to see that scanf is not going to remove any trailing white space characters from the standard input stream. So let's pop that up here. All right. Add this to the project. Pull out the old example. All right. So here, example 5. Its purpose is to illustrate that scanf does not remove white space from stdin. Remember, that's the standard input string. We're going to illustrate then how %s uses white space to terminate reading in the string. Let's look at this program. Here then we have this character array named MSG. We're going to run this program and tell the user to enter the message. We use %s then as the specifier to read the string and store it in message, and then we'll print that back out. And so let's go ahead and build and run here. All right, so if I type our hello world, so hello space I typed and world, I'm going to hit the enter key. Let's see what gets printed out here. All right, so we see then MSG HELLO got printed out, and that was then caused by this printf statement. Let's just go ahead and use the debugger to run through this. So run the cursor here, enter message once again, HELLO space WORLD, enter key press. So now back in my program, right, it's waiting to execute this line. Notice here in MSG, we have HELLO, and then there's the null terminator. And don't worry about the other garbage to the right. What's really important is we have this null terminator here. All right, so now when we execute this printf, we'll see that it just prints out HELLO, does not print out the null terminator. So next line, right, pop up our output, we can see that printf then printed out the string hello. Now, we declare then an integer named C. And we're calling the getChar function. The getChar function returns an int data type. That's why I made C an int. So we call the getChar function. And remember, getChar is going to return the next character from the standard input stream. And if you remember then, I typed HELLO space. And the way that this pattern matches is this stopped reading the string when it encountered this white space here, this space. So the next character that's read in should actually be the space character. So if I just say next line, C has the value of 32. Well, 32 is the decimal value for the ASCII blank space character. So it read in that blank space from our string. Now what we're going to do is we've got a while loop here, and we're going to say while C is not equal to that new line or that enter key press, we're just going to go ahead and print out what's stored inside. that character. So next line, right, that was equal to blank space. This will be true. So now we print it out. So notice here, we're printing out then C, colon, space. What gets substituted in here for the %5D, 5 is a field width, 5 characters wide. It says interpret what's stored in C is its decimal version. That's why we see the 32. And the next thing it says, go ahead and use 5 spaces to print out what you interpret as the character %C. Well, it can't, when it's printing a space, it's printed that on the screen. We can't actually physically see that though, can we? The next thing is we're going to then call getChar again and store the next character in C. So the next character should be our W from world. Let's say next line, right? W then is the ASCII value 119. And so W won't be equal to the new line character. So now when we print that out, we can see we've got our 119 and we've got our W showing up. We hit our next line here. We'll read the next character, which is the O. And we pop that up, we get the O. We read the next character, get charted with the R here. All right, so we'll print that out. We see we get the R. All right, and we'll read now the next character, which is the L. We'll go back through, we printed out the L. We're going to read in the D. All right, we'll keep doing this. Right, we've got the D. The next character we should read is that enter key press for that new line character. So we'll see then this test condition becomes false. C will actually be equal to that. We drop out of the while loop. And now we're going to print the new line character because that's the last character that stopped this. So we'll see then what that value is. We should throw this on the screen. Notice the ASCII or the decimal value of that new line character is 10. Right, that's what popped up. When we said to print the character version of that, well, what it actually did was that caused the cursor to go down to this next line. Right. So this whole example, right, was to show you then that Scanf does use that pattern matching of wherever there's white space, it's going to stop reading things in, and the rest of it was to just show you what characters were still left out on the string. Right, let's just go ahead and run this again. Right, if I type ABC space EFG space HIJ, hit the enter key press. Right, what gets stored in the message is ABC. There's that first white space character. The rest of this is still left on the string. This shows you then that Scanf does not actually read in this first space, right? That's still out on the string. All the rest of this is still on the string. So pattern matching for strings, as we said here, right? We're going to skip over any leading white space. We're going to read characters until it encounters white space, and we'll still store a null terminator at strings end. So you should practice with typing in different strings and seeing how that behaves to get used to the way the pattern matching works. Okay. Now there's another new function we're learning in this chapter called gets. Gets is, think of that as get string. It's ending with an S, so think of S as string. Get string. And what gets then requires is we have to pass a pointer to a char data type to it. Right, this is its function prototype. So the name of the function is gets. Here's its parameter list inside the parentheses. Right, then the data type of this parameter. So this parameter name is str. Its data type is char star. Right. So we'll read then the function description. It's going to read characters from standard input, right? That's attached to our keyboard, and store them as a string into str. So whatever argument we pass here, it's going to store that into that argument. It's going to read until a new line or end of file character is reached. So Scanf, remember, it terminates then with white space. This one is going to read until it finds that enter key press, that new line character. The ending new line character is not included in the string. So we'll read everything and store everything in there except for that new line character, and it will append the null terminator, the \0. Right? It returns then a pointer back to the same array. So if you want to capture that pointer, you can. A lot of times we don't actually write this to capture the pointer. We assume it works. But if not, so on success, it's going to return a pointer back to the same area of memory you gave it to store the information in. If it fails, it actually returns the null pointer. Right, so let's take a look at example 6 that will use gets to actually then read in a string. And this note here reminds you that gets will read multiple words from standard input, including the enter key press. So let's just go ahead and run this program and observe its behavior. All right. So gets is going to skip over white space in between strings. Right? It's going to keep reading until the new line character end of file is encountered. Let's just go ahead and build and run. All right, so if I type in hello world, hello space world, hit the enter key press, then we see that we're actually, gets is going to store both words in there, right? I'm going to, then let's run through this line by line with the debugger. All right, so here, run the cursor. So we've declared, once again, this character array, MSG, has room to store 80 characters. There's 80 chars in it, right? It executed the printf, which is telling me to enter a multiple word message. So, all right, I can't enter that yet. So now gets is going to read that message. So here's how we use the gets function. Here's the name. Inside here, I give it the name of my character array, which is MSG. Right, I'm not checking the return value on this. I'm assuming it's going to successfully store information inside MSG. All right, so if I say next line, now it's waiting for me to type something. All right. Hello. Goodbye. All right. Later. All right, so I typed in multiple words. So now here we're just waiting to print that out. Let's look at what we've stored in memory. We can see then hello space, goodbye space, later. And I actually hit a space at the end of later before I hit the enter key press. All of that is stored in here. And so next line then, right, we can pop this up. We can see it printed all that out. Now here, I've declared then, once again, a variable named C. It's of type int. We're going to call getChar. Remember, getChar then will return any characters that are out there. And we're doing this to see if it removed all the white space from the standard input, right? What we're going to see is that getChar is going to pull in that enter key press. So next line, getChar has a value of 54 here. It pulled that in. All right, right now this is waiting then. Actually, I don't know where my debugger went. Let's just stop this. All right, so let's do run to cursor once more here. Let's just work with our hello space world, 2 words, hit the enter key press. All right, so message has hello world. I'm going to call getChar, so next line. Where, oh, this is waiting out here for me to hit the enter key press. That's why, because the point of this was that it actually pulled this in. Let's go back to how we defined gets. Right, we said that the ending new line character is not included in the string. It stores them in the string until the new line character is reached, right? But it's not included in the string. Well, what it does is it actually pulls that character from the string, right? The point of this example is that until we type something, getChar is not returning anything. Let's see that again. So here, let's just go ahead and run this with 1 word. Run to cursor. So I'm just going to type in hello and hit the enter key. Right. So notice now our program is sitting here waiting. It's waiting for this getChar to execute. And if I say next line, that means now that we're waiting getChar. Notice how the cursor is still flashing. That's because there's nothing there for getChar to read. That's because gets remove that new line character from the string. If I hit then, I'll just type world here now. Notice get char still not returning. Remember, get char doesn't return until we hit the enter key press. So I type world, hit the enter key press. Now in here, let's watch what this does. So now we have the W. We're just going to go ahead and loop through this and print out everything. So this is going to read the W, the O, the R, the L, the D, right, and the enter key press as it cycles through. Right, we can see when it got to that enter key press, it's printed all of that out. We'll print out the last thing we read, stored in C, which was that enter key press. We'll see the value of 10 there. Right. And so you should spend some time with these programs, right? When you're going to use these functions, it's sometimes important for you to know then whether gets removes that new line character. It'll become important if you're trying to do multiple reads in your program. If you're only ever trying to read one thing, it's not quite as important. Right, so for these input functions, right, we have to play with them a lot to understand how they work in different scenarios. The important thing for gets is to realize then gets then skips over white space. It's going to keep reading until it hits that new line character, that enter key press, or an end of file condition. You will likely encounter an end of file condition. Right, it does not store that new line character inside your array. Right, and it will append the null terminator. So the difference between gets reads in several, you can think of gets as reading in several words, whereas scanf is only going to read one word or one string at a time, which is what this is summing up right here. Right, if we had this, once again, 80 character array, if we use scanf and use %s for a message, then scanf, if we type hello world, is only going to store the hello. With gets, we're going to store both the hello and the world. Right? Gets is going to remove this new line character from standard input, but scanf does not. Right? Gets will have an unsafe behavior when the string is longer than the size of the array. Right? If I were to type a string that was longer than 80 characters, gets would actually try to pull that in. We might have some memory issues there. We need to be aware of things like that. All right. So in the next lecture then, we'll talk about some string library functions. We're actually going to write some of the functions ourselves so we can understand how they're working, and then we'll learn later how to use them within the special library.